Good evening, everyone.
Good evening, sir.
Today's topic is week 5. We'll discuss on week 5. So all of you have studied or gone through the week 5 lectures.
Yes, sir.
Okay. So any doubt on the concepts? Maybe uh, you can go through again and again the lecture, then concept that doubt will be resolved. But although any conceptual doubt, anything, and we have a test, right? In Feb, I think.
Which test, sir?
Quiz 1.
Oh, quiz one is on 30
Oh,
January. Yeah.
okay. So quiz 1 syllabus, right? 1 to 4, week 1 to week 4. So
Yeah.
week 1 to week 4 is quiz syllabus, and week 5 will come in week quiz 2. So anything. So all of you are right now preparing for quiz 1, I think. You can, if you don't want to speak anyone, then you can write in the chat box also, so that I can know what you are saying or what. Okay. So all of you have gone through week 5 lectures? No, yeah, that's why I was asking. Okay. Yeah, some are 3 lectures. Okay, yeah. Actually, today's agenda is week 5. That is why I was asking. Tomorrow we'll have a revision session or something about the quiz. Will cover tomorrow session. Uh, okay, most of you haven't seen, I think, week 5 lecture. It is totally based on the graph. Uh, Previously, the week 4 lecture was okay. So overall, what is your feedback about the
Hello,
uh,
no voice,
hello?
no sound.
So am I audible?
Yes, sir. You are audible clearly.
Samit Sen, maybe it's something has happened to your end. So I'm you can write in the chat box also. So what I'm asking, that what is feedback up to week 4 or week 5 you have studied, means about the PDSA. So uh, what all of yours view means, is it difficult, easy, medium, or anything else you are facing difficulty while studying these 4 5 lectures, or application is quite tricky. Yes, uh, I think, uh, yeah.
Yes, sir. The difficult part is to convert the logic into code.
Hmm. And especially from graph lectures, I think from week
Ye-
4.
Yes, sir.
Hmm. Right. So any all of you, I'm asking from all of you. You means all of you. So uh, I am dividing. I am just dividing this course into before graph and after graph question. Okay. So before graph, uh, what is your feedback? Means if you uh, leave the week 4 and week 5 lectures, and then the rest of the lecture like week 1, week 2, week 3, because all of you already have studied Python, right? So, and week 1, week 2, week 3 is related to Python, but with the data structure. So have you faced difficulty uh, in those lectures also while coding? Those who don't want to speak can write in the chat box. No issues. And okay.
Yes, sir. Actually, we faced difficulty there also.
Oh, there also. And if you uh, yeah, some are facing difficulty while solving those coding question. If you are facing difficulty in week 1, week 2, week 3 lectures, then definitely you will face you will be having a problem while coding in the graph section also. So what I will suggest, that try to code as much as you can, take help from geeks of geeks, or take help from another hacker earth. Any, no, I don't recommend hacker earth. Hacker earth is a bad platform. Hacker rank, or no, today's agenda is week 5, week 1 to week 4, or mock problem week 5. You know that this is week 5, and this is first. uh, what about code safe? So I don't know about the code safe contest. Code safe contest will be intimated you by the email or something, whatever the means is. So I don't know about the code safe. And don't worry about code safe. Focus on the quiz one. So all of you know, right? That what type of question will come in quiz one.
No, sir, not clearly.
So okay, okay. Some are writing mock complexities. Hmm. So what I'm saying, quiz one will be based on week 1 to week 4, and the difficulty will be the same as practice problem, not the coding. I'm talking about the objective, practice and graded. The same type will be asked in the quiz one also. So same difficulty level and same type of question also. Same type of question, nothing else. You know that what else we can make, right? From the and whatever will be whatever the question is, it will be asked from the lecture, not any. I don't think that uh, yeah, so mock same last term's mock. Sorry, I don't know the last term's mock and this year's mocks. I don't know about the mock, whatever. But you practice the question on practice assignment, whatever you have done in week 1 to week 4, the practice objective and graded objective, the question will be a similar type of question will be asked. The same concept will be the same, but different types of question, the we can ask on the concept, like uh, suppose there will be a definitely there will be a question, like there will be a coding, some snippet of the coding, and we'll ask that what is the time complexity. So this type of question you have already done in week 1, week 2, or week 3. So these type of question, like Bellman Ford, suppose Bellman Ford, oh sorry, Bellman Ford is week 5, right?
Yes, sir.
Okay, so uh, Bellman 14 week 5. Okay. So what was in the week 4? It was depth first search or breadth first search. So the question will be like, the what is the properties of the breadth first search? So uh, you can guess that, yeah, these are the properties of the BFS or DFS. So pick one or more than one property will be asked in the question. So these kind of question will be asked in the quiz. So no issues. And the quiz one is very important. This year we have quiz one, quiz two, and in same exam. Previous year we have a 3 quiz, but this year we have 2 quiz. So give your best. Topological sorting. What topological sorting means? Means what do you want to ask?
You were
Topological.
saying it was in week 4 topics. You were asking me.
Okay, okay. Yes, yes, yes. So these you can guess that from topological sort what we can ask, right? Maybe a graph will be given, or any graph. So we can ask that what is the pattern according to topological sort, or we apply any topological sort. So what pattern we can find, right? And the properties of the topological sort. So these type of question will be asked. So and oh, stability of the sort. So okay, so everyone knows the stability of this sorting algorithm. So anybody knows? Anyone? Hello, hello, hello. Oh, okay, it's off. If an
Sir,
element is present.
sir, this is Bipin here.
Yes.
I have to ask this question um, about the how the quiz numbers are going to add up eventually in the end. So we have like quiz 1 and quiz 2, and we'll also be having programming quizzes for PDSA.
Programming exam, right?
Programming exam.
Yes.
So there are going to be two quiz 1 and quiz 2, and there are going to be two programming quizzes also, right?
Two
Only one
program.
actually.
No, only 2 quiz, one programming exam, and one in-sem exam. 4 exam total.
Oh, okay. So only one programming quiz. Okay.
Yes.
Okay, understood.
Code safe is different, right? Code safe. Oh, so anyone, yeah, someone is writing about the stability of the sorting algorithm. So he is right. So who is, so can you explain us? So I can give you a brief and okay, first, okay, okay, nice. Okay. So stability of any sorting algorithm means, suppose that we have 1, 2, 5, and 2. Okay, 4 elements. 1, 2, 5, and 2. So when we sort this 4 element, so the sorting will be 1, 2, 2, 5. Okay. So
So
this,
if you're presenting, it's not visible.
no, I
Can
am
you
not
share?
presenting. Okay. I'll write in the whiteboard. Okay. Wait. Okay, give me time. So all of you can see my screen.
Yes, sir.
Yes, sir.
So stable sort is like here 1 2 5 2. Okay, so this is uh, one arranging order of means one pattern, and this is 1 2 2 5 after sorting. So in a stable sort, you can see there here 2 is 2 times here and here. So if we apply any sorting algorithm in such a way that these two definitely will, because you know that these two be uh, will be neighborhood, actually it will be neighborhood, right? It will come before 5. So which two will come and which two will be after the previous one? So which two will be the first one? So if you know that this two is uh, before this two, right? In the original pattern, this is earlier than this one. So after any sorting algorithm, if we apply any sorting algorithm to sort this pattern, so if we find that this two comes before this two, right? Because in the original pattern this two was after this two. So if the order maintains for two common element, if the order maintains after the sorting algorithm, then we can say that this sort is stable sort. Otherwise we can say that this sort is unstable sort. So this is stability means.
Sir, is there any mechanism to check that first two comes
No,
at
no,
first
no, no, no,
in
no,
first
no
order?
mechanism, no mechanism. Mechanism is like if you apply any sorting algorithm and you have to check if suppose new sorting algorithm has been found, means breakthrough algorithm, any new algorithm found. So we will check those, we will check any pattern, we will check those algorithm on any pattern, and then we'll check that yeah, this two is earlier than these two, means it is maintaining the order of the same element. Then we can say that this is uh, stable or not, because we know that already already we have studied some insertion sort or bubble sort. This is stable, right? Okay, so can you apply insertion sort here, anyone? So who was asking if you apply insertion sort here, so you can see that uh, pattern will be the same.
Yes, the 5 and 2 will be swapped at some particular iteration.
Yes, so pattern will be same if you apply insertion sort. Then you can see that everyone can check that insertions, because we already know now that it is stable, insertion is stable. So we can say that if we apply insertion here, definitely two will be the order will maintain, we can maintain order. So like insertion sort also, bubble sort also, stable sort, merge sort also, stable
Sir,
sort.
but if you attach an alphabet to these all numbers, like in the first case, if you do B, C, D, and A, will it be still stable? If you do
B,
B, C, D,
C,
and A.
D and A. Okay, so what do you want? A
If you
should
so
be earlier, A, B, C, D.
yeah, and if you see this is like a tuple 1B, 2C, 5D.
1 minute, yeah, huh. What is example?
If you take it like a tuple 1, comma B,
Triple one,
no 1, comma B,
1, B.
yeah,
Okay,
and then like the next element 2, comma C,
2, C,
and 5, comma D,
5, D. Okay,
and 2, comma A.
2, okay.
Then the sort, like insertion sort, won't be stable here, right? Because 2C would come before 2A.
So what is insertion sort? Insertion sort just insert in a right place, right? It just choose and then it just swap element, it's just swapping the element. So you have to first you have to decide on which order you want to you know that uh, here are two elements, so you can decide in which order on B C D A you want to sort, or 1 2 5 2 you want to sort. And in this example B C D A all are the different like A B C D, so you cannot say that it is stable or unstable. It is not the decisive criteria here. This example we cannot take, because for stability, to check stability, we have at least one element which is 2 times or 3 times, then after we can check, right, that order is maintaining or not. So BCDA all are different, so how can we check here the stability? It will just sort this example as ABCD, and here we have to first decide that we want to sort 1 2 5 2, because this is the tuple and we cannot do two things at the same time. Means 1 and A, because it's like 2 and A is combined, C and 5 is combined, B2 or 1B is combined, 2C combined. So we have to decide, right, 1 2 5 2 we are taking, or BCDA we are taking. So what you were saying about 1 2 5 2, so if you take 1 2 5 2, then 2C will come before 2A, and then we can say that it is, yeah, it's sorted and it is stable sort.
Okay, sir. Okay. I thought that 2A should also come before 2C. Then it would be stable.
Yes, 2C will come before 2A,
Okay.
means 1 2 and 2A, then 5D.
So it means we can talk about stable sorting when there is common elements.
Yes. Otherwise you know that definition of stability is we have to have a common element, otherwise we cannot talk about, right, so how can we check the stability? If we are, definition is that if we have a two common element and one in the original pattern, one is earlier than second one, then it should be the same after sorting also, then we can say that it is uh, stable sort or unstable sort.
Okay. So, and what about in place sorting?
In place, in place means na that if you are using any extra space for sorting, if you are using any extra space, then you cannot say that it is in place. If you are not using in extra space, then you can say in place. It's like merge sort. Suppose take merge sort. So in the merge sort we have given an array, right, and after dividing and merging together we need one extra array, right, we need one extra array, we take one extra array of size n or m, so there we are using extra space, right, so it is not in place because we are taking extra space. So this is not in place. In place we usually do not take any extra space, we just whatever we have given the size of array, we just swap, and whatever the operation is, we perform those operation on those that provided in that provided space, we just perform our operation. So that will be in place sorting. Means sorting algorithm is in place, not in place sorting. Sorting algorithm is stable or in place. So during merge sort, so merge sort is also a stable sort, right? along this
Yes,
code
yes.
merge sort. You can check yourself, right? Merge sort, you apply merge sort because you have already studied merge sort. So suppose, okay, we will take right here example, and can anyone from you guide us? Okay, we'll take example here. Here we are taking example. Oh, where is? So 1, 2, 3, 4, 5. 4, 5. Okay, this is, suppose we have sorted, right? And second one is okay, 4, 5, 6, 7. 6, 7, 8. Okay, so so any one of you, anyone, try this. What should we write here? We are applying merge sort. We have already two sorted element. That's what we do, right? We have a two sorted list, and we want to, and we are just merging it.
Mm.
And we have a common element here, 4 and 5, 4 and 5.
Mm.
So what we do generally in merge sort, any one of you have, so all of you have already studied merge sort, so please speak, anyone. So by this way we can verify, right, stability.
Right. So we can just declare
Insert.
two variables, I and j equal to 0.
So please tell me your name. What is your name?
Madhav.
Oh, okay, Madhav, please.
We can declare two variables, I and j equal to 0.
No, don't need to say this one, right? I, J, K. Just we just guide us about 1, 2, 3, 4, 5, 6, 7, 8. So one should be compared. So by this way. So all of you, please listen. Yes.
Okay. First 1 and 4 will be compared, and
Okay.
one will be pushed into the.
Okay. So one, I have pushed one. Okay.
Then 2 and 4 will be compared, 2 will be pushed.
Okay. Yeah, I have written two.
Then 3 and 4, 3.
3 and 4. Okay. 3.
Yeah.
3 and 4 is compared. 3. Okay.
Yeah. Then 4 and 4. At this time, both the 4s will be pushed. Like first this 4, then from 4 from there.
No. Right here we can decide. Okay. So what was the chat? Okay. During merge sorting, if both lists have same element, for example, say 2 in both lists, then how we decide stability, which list 2 will come first, stability. Then okay. So here we will take that, you know that if 4 is less than or equal to 4, then what we took from this list, right? From this first one,
Yeah.
Yeah.
not this one, right?
Yeah. First, from the left 4 will be taken first.
So
That's why it is stable.
yes.
First left 4 will be taken. Yes.
And you know that this kind of sort, so suppose this 4 is here, it means what? It means that it will be some left part of it. It means, suppose, means original list will be like, suppose something like 1, 3, 4, 5, okay, then 6, then 4, then 5, then 7, then 8. Okay, so because what I'm trying to say that this 4 is this 4, because when we divide this into two lists, so definitely this 4 will be in this list, right? This 4
Yes.
will be this in the left part of the uh, that in the left part of it, means when we divide these two in the first part and second part, then this 4 definitely will be part of this 4 this list, and this 4 will definitely be part of this 4. So this 4 is same, because we that we just divide left part into another two left part, right part into another two part. So this 4 and this 4 is same. So everybody understood, right? So 1, 2, 3, 4. So this 4 here, this 4 and this 4, we compare this 4 and this 4, and we have decided that this is equal to this. So we will take 4 from this list, not from this list. Okay, so everybody understood, right?
Yes, I understood.
Okay, and then again, Madhav, please explain us.
Yeah, from we will be taking the left 4. After that, 5
5.
will be compared with the right 4.
Yes,
Then at that time 4 will be pushed again, the
yes,
right 4.
yes,
And again 5 will be compared with this 5. Now left 5 will be pushed.
yes.
Then after that only the right side will
Yeah,
remain, that
6,
we will be
7.
just attaching.
So everyone understood, right?
Yes, sir. Got it.
So whoever wrote the chat understood, right?
Yes, sir.
Yeah, so that's why it is stable sort. And here, that we are just creating one extra space to merge these two lists, right? So that's why that is why it is not in place, because we are using extra space, right? We are creating extra space to sort. So this is stability and in place sorting.
So,
Yes,
may I ask a general query?
yes.
So in quiz, we'll get the same number of questions as in mock.
Okay, let me check the mock first. Okay, I'll tell you. Let me check the mock first. Joyce, can you mute? Oh, okay, 16 question in mock. Yes, yes. Same number of question will be there. 50 or 16.
Okay, sir.
Same. And the level will be same. That same question we have asked, right, in the mock, and the same kind of question we have asked. So it will be the same in the quiz also. Same kind of.
Sir, can you discuss 13th question of mock?
13th. Okay.
Yes, sir. 1-3. Yeah.
Can anyone tell us the 13th question?
The 13th one is if you split it in two parts, because 6 is the middle element. So first part there is a
Wait,
4.
wait. Yeah, I'll get back to you. I'm just opening a question. Yeah, Samit, I'll
Yeah.
get back to you. Yes, Sumit. Yeah, Samit. Yeah, Samit, please.
Yeah, so the 13th, the question that in the DAX are you can split in two part. So before 6 one group, after 6 one group, because 6 is the converging point. So before to reach 6 there is 4 step, means 4 way I can reach. So there is 4 possibilities, and after 6 there is 3. So if set 1 and set 2 if I combine, so total 12 combination is possible. But the criteria is given only that 2, 3 and 8, 9 criteria. So this basically out of 12 eliminate 2 of the combination. So total 10 combination is net possible. That's all.
He's right. Good. So Madhav,
Sir, I couldn't get that combination, like 2, 3 and 8 should occur before. Yeah, 3 and 8 should occur before.
so Samit, please explain us once
So
more.
if you can
And
open the diagram, then I can tell here. So
okay, I'll share. Okay, I will share. Okay.
Yeah.
Yeah, I'll share, and please.
Yeah.
This is the question, right?
Okay. So in this graph, the in degree is 0 only for 1 as of now, right? So
Yeah.
so we can start with 1. Now after 1 is removing, the 2 and 3 both in degree is 0. So this is our choice. Either we can choose 2 or we can choose 3 to enumerate the graph. Now first I am doing up to 6, and then I will do from 6 to 10. This will make easy in your journey. So one of the option is reaching 6 is 1, 2, 6. This is one option. And another one is 1, 3, 4, 5, 6. This is another option 2. Another one is 1, 3, then 2, then 4, 5, 6. And the last option is 1, 3, 4, then 2, then 5, 6. So this is the 4 option from where you can reach from 1 to 6. Now come to the second part. From now 6 is in degree 0 because this 1, 2, 3, 4, 5 we have completed. Now from 6 to 10 you can go either 6, 7, 8, 10, means 6, 7, 8, then 9 and 10, or else you can go 6, 9, then 7, 8, 10, or 6, 9, now 6, 7, 9, 8, 10. So this is the 3 option you are getting. So if you want to, if there is no constraint is given, so there is 4 into 3, that means 12 possibilities, 12 set of graph I can reach from 1 to 10. Now one condition is given, 2 appears before 3, then 8 must appear before 9. That means right hand side condition, say when I am going 1 3 4 5 6 or 1 3 2 4 5, in this all this condition, when 2 doesn't appear before 3, then 6 7, this right hand side 8 appears must before 9. It's not means
Yeah, not
mandatory,
required. Not
not
required.
required. But when 1 2 this is done, then I cannot go without this 8, then 8 must be appear before 9. So when you have this first choice, then there in this side 2 choice, you have to omit, because you can't do that. So that is why two set of means choices you lose when you have imposed this constraint. So 12 minus 2, that is 10 condition.
Yes, he is right.
Got it. Got it. Yeah.
Yes. So everybody understood. So it is simple that we know that in the topological sorting, what we do generally, that first one will come before this, right? Means one will always comes before two, because it's in degree 0. So by in degree we can say that we can choose in degree 0 we can choose, then remove, then we can select 2 or 3. So if we remove 1, then we will have 2 and 3 in degree 0, so we can choose 2 or 3. So you know that we have a 4 option here and 3 option here, so total 4 into 3 we can select, right? Because for any one option we can choose any one of them from 6 to either here. So for 4 option, so why 4 into 3? I'm telling that because for any possible path you can take here, so there is 3 possibilities, right? So we can choose here, so that's why 4 possible paths here. So here is 3, so 4 into 3, so that's why 12 will be there. And you know that we have uh, 2 condition here also, that 2 appears before 3. So you know that 2 should appear before 3, so one option is eliminated right there, that 2 will be because here we can take 1 3 4 5 or 1 2 3. So we have omitted that 1 3 something, 1 3 2, so we have already omitted that. So you know that we have already omitted, so we can omit that that case. And here also we have 8 comes before 9, so we can omit here also the one path. So means with that combination we can when you combine those combination, because you are just combining those, means for every path we have 3 options. So for that path we drop that path, like 1 3 2, we have dropped that path, and we have dropped that path also, like 198 something, so we have dropped that part. So that's why uh, you know the combination will be reduced from 12 to 10. So that's a simple, uh, we can simply draw these things. Definitely uh, if you are not thinking in such a way that you have to make 12 combination and then you have to delete 2 3 4 whatever the option, so it can take your time. So do it in this way, that can save your time. Otherwise, if you draw a pattern and then eliminate, then it will take at least 8 to 10 minutes, maybe 8, and then after, so
Sir, I'm not sure if it is true or not, but in this graph, I think there is only one way in which 2 comes before 3 and 8 comes before 9. Like there is only one path like that.
no, 2 will be okay.
Like
Okay.
satisfying that constraint, that specific constraint, there is only one path, I think.
So,
Okay,
Parth,
okay.
actually,
1, 2.
it's only one path, but since this left-hand side graph is converged to 6 and
Yes.
right-hand side again splitted and you can reach, see, after you coming in number of way to 6, then you can go m number of way to 10. So one of the path is get means your constraint, but the rest of the path you can reach when you have do not choose this 1 to 6 this path. So all these possibilities you have to consider, and that is why it is 10 minus 2 is coming.
It means number of combinations we have.
No, this is true for this kind of graph. It's may vary with the graph gets changed.
Yeah, here it is because of the 6 we are getting this kind of thing.
Yes,
So
yes.
actually that is why here we can make a combination right from here. So that is why because of 6 we are getting this kind of thing.
Yeah.
So like after one we can take 2 or 3. If we'll choose 3, we can after that choose 4 or 2. If we'll choose 4,
No,
then we can
we
choose
cannot choose,
2
right?
or
2 appears before 3. This is the combination, right? Two should be earlier, right? 1, 2, 3 something.
When in the graph 2 appears 3, then 8 must appear 9. This is the condition is given. But when
Yes.
the 2 doesn't appears before 3, the when my graph is reaching from 1 to 6 is 1, 3, 2, 4, 5, then I can go 6, 7, 8, 10, 6, 9, 8, all these things is open for me. But when the graph is 1, 2, 3, 4, 5, 6, then I am stuck.
Yeah,
I have to go with 6, 7, this
yes,
8, 9,
he's
10.
right. He is right.
So this is the condition. Sir, in question number 14, if you go down, question number 14. Yeah, I have actually I have some problem to no, just wait. Yeah, there is 3 possibilities is there: best case, worst case, and average case. So complexity calculation, best case and worst case, I can understand. Okay, this is the reason that is worst case is coming or best case is coming. But I always find a problem to calculate the average case. How you find this average case? Can you, sir, please explain? Because I am not very comfortable to calculating this average case. I'm not getting it, how people are calculating this average case. Best case and worst case, I can understand. But how you calculate the average case?
Okay, so give me an example of best cases, any sorting algorithm. So best cases means what? What do you understand? Best cases means everything is sorted. Suppose any sorting algorithm, anyone, and sorting algorithm, the best case is like it is already sorted. If element is already sorted, then the best case will be the same. Okay, so this is the best case. So, and the worst case, suppose that it is, if it is in opposite, sorted in opposite order, then for that algorithm it will be the worst case condition. Okay, so this is best case and worst case. Suppose that if it is neither in best case, means neither sorted in correct order and or nor sorted in opposite order, so what? So in that section, in that case, you can say you can count those algorithm. Okay, you can count time complexity on those example.
Here is my problem, sir. Suppose you take any shot, so simple, for the simple selection shot you take any shot. This is not depends upon the shot. The question is when your average case, what does it average means? Means all the possibilities of the means possible numbers I will generate.
No, that's what I'm saying. if anything that is not the best for that algorithm and that is not worst for that algorithm in general, because that's what I'm saying, that previous example, if our pattern is neither in the sorted order and nor in opposite sorted order, so it means that it is a combination of those two, like elements are arranged in randomly. So then there you can check time complexity of algorithm, and that will be the average case for this. Understood? Means
Now, how
it
to
will not.
find that, sir? How to
How?
find? The question is how to find.
So you, that the same way you have find, the same way you just you are calculating for best case, same way you can calculate for the average case. Means you didn't understand. I think you confused, right? You got confused because of this, that average case is big O of n square, worst case is big O of n square, and selection best case is also big O of n square. Means you are thinking that worst and best cases is same, like we are just calculating, we are taking just worst cases every time. I think that's
If
why,
you,
na,
sir,
right?
explain a little, then
That's what I'm saying, that
I'm not getting it actually. How average case get calculated? I'm not getting it at all. Because
okay.
what I think means what I understood and not able to, that is why I'm not able to understand your thing. I understand key, suppose there is n way I can, this program can be done, and each time the distribution also get changed. So how do you find the average one, the time complexity?
So that is not the time, that is not the way we calculate the time complexity. I
Then
am just giving you the example, right? That
sir, you
for
give one example where
suppose
the
any
best,
algorithm,
average and worst case is three different value.
that's what why I was thinking that you are getting confused between, because you have something in your mind that we are taking worst case as an average case. Is it?
That is why I have seen in everywhere it is taking in
Yeah.
that fashion. If you can just give one example where these three is different, then I maybe I'm able to understand.
Anyone knows that three different, anyone knows, I don't remember right now that three different time complexity algorithm, but please try to understand that if something is best for you, okay, and something is worse for you, but not always we got the situation that something is worse and something is best, right? You think in your life also that you didn't get uh, some opportunity like it is best, or it uh, suppose I'm just giving you an example, that suppose you are giving quiz, and the best case, what is the best case? Best case for you is that all whatever you have read, it comes, that all the question that you have read, it comes in the exam, it will come in the exam. So it is best case for you, and the worst case will be that whatever you have read, it won't come in your exam, it won't come, so this will be the worst case. Okay, so but the average case, what will be the average case? That's some part of the best cases, and some means some of question you have read comes in your exam, and some of your question which you have read uh, didn't come in your exam, right? So this is the mixed kind of example we have. So in this example, we will check that time, we will check the time complexity of the algorithm, how it is working. And you know that for example, we will how we calculate time complexity. We took some example and we try to implement algorithm on those example that it is doing well or not, it is sorting well or not, so how much time it is taking, and on an average means how much time it is taking in general. So if it the mixed cases, if you have an example of mixed cases, okay, so in that cases you generally check that what is the time complexity of your algorithm, and why you are seeing that average case and worst case is always everywhere it is same, like because we generally that order of n square plus n, so we generally neglect the n something kind of thing in the worst cases, and in average cases suppose it can be possible, right, that our time complexity for worst case will be big O of n square plus n, and in the in the average case it is big O of n square exactly, but what we write in general, what we write that big O of n square plus big O of n big O of n square and big O of n square, but it is not actually. If you can see that there is plus n time complexity included in the worst case, but it is in general we write big O of n square. Okay, so that is why it looks like same, but it is not the same. So
Okay, this one part is clear, ki why it is two look like same, but still how to calculate this average in the average condition, this is not means arriving the big O of n square or n square plus n, whatever it is, for the best case and worst case, mathematically I can come.
Yeah,
but
I'm
for
saying
the
that's what I'm saying, that in on an average you pick one example, right, for the best cases, some part of the best cases, some part of the worst cases example. Okay, so then you because every time you didn't get best cases example or worst cases example, so in general we mix we mix those kind of
okay, sir,
example, and on that example we generally check that what our algorithm doing, so what is that, then there will be the time complexity.
okay, sir, I'm posting this question in the discourse. If you
so
find one good
can I say something?
example, then
So still
Excuse me,
now
can
you
I-
didn't understand means okay, maybe what, maybe you can
So
think
can I
about
say
this.
something?
Yeah, you can say yes.
yeah.
Average case will be the most of the case, which means that is millions of cases we do sorting.
Sorry,
The,
come again.
I am audible.
Yeah,
Yes, you are audible.
We apply sorting algorithm to million of cases. We generally wait, wait a little bit.
The meantime, can you explain the question number 4 and 15?
4 and 15.
Yeah.
Four is here. So anyone knows this sensor? Connected undirected graph G has 1081 edges. So what we can say about and the number of vertices in G?
No, I'm getting actually option 1 is correct, but actual answer is option C.
Oh, option C is a actual
Yes.
answer.
if you see if it is a complete graph, then there should be 1081 edges. So if you multiply 47 with 46, which is a number of edges in a complete graph, then you will get 1081. And if it is a simple path, a path is simply connected. So if you consider it as a path, then it must have n minus 1 edges. So if there are 1081 edges, then there must be 1082 vertices in total.
The last line come again, Pras?
If there are, if I consider the graph to be a path is connected graph. So if I consider it is a path, then there must be per graph with n vertices, the path must have n minus 1 edges. So if there are 1081 edges, then there must be 1082 vertices.
Right. Thank you.
For n vertices, n minus 1 edges.
Thank you. Right. Missed that.
And it is also the criteria of the tree also, right?
Yes, sir.
And tree is
But one thing, Parth, when this 1081 edges is there, to calculate the edges, what do we generally do? The n into n minus 1 equal to 1081, right?
No. N into n minus the minimum number of edges. If the graph is connected, then it must have n into n minus 1 by 2 edges.
No. This is undirected graph, so n into n minus 1, right?
Yeah, the minimum number of edges possible will be 1082, right? So it must be 1081, right? Edges. In the whole graph, there must be 1081 edges, right? It is given as 1081. So if I consider the graph to be complete graph, then there must be 47 vertices. Because if I complete a graph with 47 vertices, then there are 1081 edges. But if I don't consider that it is a complete graph, then I go to 48 edges, 40. Then my edges starts reducing per vertex. So if I consider if the graph is single straight line path or it is a path, then there must be 1082 edges, because for n edges, for n vertices, there are n minus 1 edges. Are you getting my point?
Yeah. I got it. Good.
47 comes from if a graph is a complete graph.
Complete graph, right. So complete information is not
You say if there are
connected under.
it says that you given lower bound and upper bound, right? So if the graph either the graph is complete, either the graph lacks some vertices on some edges on some vertices. So as the vertices increase, the number of edges per vertex, number of edges per vertex decrease. So if you see that the graph is a path, then there must be 1082 edges. Bare minimum this much edge vertices must be there.
So what I can say that do not think in this way. If you want to think in direct way, that you know that for connected undirected graph, we have minimum number of edges could be n minus 1 by 2, right? N minus 1, n is number of vertices, right? Means edges could be n minus 1 by 2. Number of edges, it could be n minus 1 by 2 for minimum number of vertices we can get. So if you can say that n minus 1 by 2 is equal to 1081 edges, it is n minus 1 by 2 edges. So if you can see n is number of vertices, so if you solve this, n minus 1 by 2 is equal to 1081. So definitely, because it is a quadratic equation, so you can get that 47 something, and what could be the answer? 47 or 46, right? So 47 or some 46, I think. So there, from there you can get that 47 or 46. So the lower bound we can find out that whatever it will be, 47 or 46. And we know that for n vertices, exactly, not the exactly, n minus 1 edges maximum if it is not a tree. Connected undirected graph can have a cycle also.
Sir, in the question, in the answer, the edges, vertices vary from 47 to 1082. So if you consider the upper bound, if we consider the upper bound 1082, then there must be 1082 minus 1 edges to connect the all the vertices.
Yes, yes, correct. Correct, Paras.
And all the vertices on a single line for the maximum, for the
Yes, yes, yes. You can draw in a single line.
yeah. So that will be the maximum
Number of vertices.
Yeah.
And the question 15, anyone that, or please explain. 4 is clear.
Can I speak now about sorting?
Yeah,
So
yeah,
what
sure.
is 15?
Sorry,
Yeah.
my little brother has come. If I don't mute, he unnecessarily make a lot of noise.
Yeah.
But, see,
So
I was
anyone have
saying that
solved this?
you also watched in video. The professor has derived all algorithm on general cases, not on a special case or best case. After that, he says that this is the best case, this is the worst case. He derived all algorithm on general case. Means the average case is that general case. Any logarithm may be efficient, very much efficient on some particular cases. That is the best case. For example, maybe already sorted list. It will means take very less time, or maybe descending order of list take too much time. So we can't say that this is the time complexity for that algorithm. That are only two cases. For example, in quick sort, and lists like which are in ascending order or descending order, or list which has same elements throughout the list, take n square time, and the rest of all lists take n log n time. That's the average case, n log n, and and these three cases are the worst case, which is n square. You can say that worst case is means for 2 or 3 cases. Best case will be 2 or 3 cases. Rest of cases are like average cases.
But is it necessary the rest of the cases always the same complexity will come? You got my point. Suppose there is total n possibility, as you said, 2 or 3 is the best case and 2 or 3 is the worst case. I understand. So remove that. So n minus 7 cases or n minus 10 cases will be the average case. But what you are explaining now, for each of those n minus 7 cases has the same time complexity. Is it true?
No, that's why we take average.
I'm just asking
not
that.
Lot of margin. Not lot of margin will come.
Yeah,
Like
it's very difficult to calculate.
Some margin will come that we ignore, like 0.2222 second, like this.
Okay.
Major difference can be seen only in best case or worst case.
Yeah, that is
we can see major difference. The
That's
rest of case we check significant difference which can ignore. If we see differences like means not only in worst case or best case, there will be 3, 4, 5 cases stepwise, then we can't say that algorithm is efficient, because it is a broken, stepwise broken, like one step gives n time complexity, other n log n, then n square, then n cube, like that. Then we can't use algorithm for sorting. So there will be only 2 cases, worst or best, and 1 average case for total algorithm. That's called average case, not a stepwise broken, which you are saying.
Thank you. Problem 15, sir.
Okay. So is the answer is D?
No, sir. Hey, what do you say? D for Delhi?
Yes.
No, no, no. We are saying ki B for Bombay.
Okay. So we know that anyone has solved already this 15. So we know that in binary search, the what is the best cases, and best cases comes when anyone knows.
The login time.
But what is
Oh,
login
best
time
cases is the one, order of one.
and when it comes?
When in the very first, the middle element is the searching element.
And what if the element is already sorted?
And what we are searching, no, it has to be sorted first of all to do the binary search.
So
And
that in that case we can get right log n.
Sorry, sir, I didn't get you. What?
Suppose element are sorted 1 2 3 4 5 6.
Yeah.
So we'll get to the middle element, and then we can find that we will go in the left side, or if suppose we are searching 1 or 2 something, if element is sorted, then we can take log n time.
The worst case is the login time.
If element is sorted, so we can take log n time. So here also each row is sorted, okay, and each column is also sorted. So we have to search any element. So what we can do, how we can do proceed in the suppose in binary search, if we go to the first row, so we can say that if element is present or not. So at most we can take log n or log m, maybe whatever the size is. So for first row it can be log m, right?
No, I'm not getting, sir, because this is a matrix is given, right?
Yes, that's
M,
what
M cross n. Now to access
n cross m, yes.
To access into the element of a matrix, we need to go row and column both.
Yes.
So when you are entering row into column, then I'm not getting this log m star log n.
No, I'm not talking about the answer.
Okay.
So I am discussing that how we can search or how we can apply binary search here. So I don't know. Okay, we'll do together. So I am also seeing the first time this question. Okay, so how we can do? So we have an element. Okay, so we can go in the first row, means first row and all the column. Maybe what we can do.
Yeah, that's what I initially thought. How we search? Now we will search go to the first row and then apply the your this thing.
Yes. Okay. So maybe
Okay, sir. I got it. Right. It is log
So
m star
first
log m.
we search through the column, like first column we search and
yes.
then
Maybe
log
we can
in.
go into the column wise, or maybe we can go into the row wise also.
Yeah.
In both
No,
the
first
cases, we
sh-
have to give this binary search. Means when we will traverse the column, we apply the binary search.
Binary search,
And
yes.
also the row, I will not go 1 2 up to n. There also I give the binary search.
And we know that if the element is in increasing order or decreasing order, then it takes log n or log m something.
Yes, right,
You
right,
know,
right. Correct.
right?
Clean,
So
clear.
by this way, you know that I am just seeing the first time this question. I am also. So this way we can think, right? If anyone is facing difficulty to calculate time complexity, so by this way we can think of that how
So
to.
this is to, we assume that all the elements are distinct, right? Because in bind,
Yeah,
yeah,
we,
right?
yes,
Yeah, if
right.
you don't assume it is distinct, then this won't work.
So we can, on an average, we can assume that that
You
elements are
know,
distinct.
that is also while we are doing the binary search, we, by default, we are always taking that elements are distinct. If it is not
Distinct,
distinct,
distinct. Yes,
then we
yes,
have a
yes.
trouble. We have a problem.
If element is same, like 1 1 1 1 1.
But I don't. Is it problem or because even it is not distinct, then the array is sorted, right? We
Yes.
shouldn't have problem to find that.
So no, no, no. What I'm saying, if element is not distinct,
Hmm.
it means that 1 1 1. Okay.
Hmm.
So what
We
is
can get
need?
the element
Yeah.
we need to
What is need? What is
yeah.
need to apply binary search here?
No, no. What he is saying, suppose the element is 1, 2, 3, 3, 4,
Okay,
5,
okay, okay.
6, 7, 7, like that. If it is there, then
Oh, then nothing will happen. It will take or log n, order of log n,
yeah,
log
it
n
will
or log m.
again take log m or log n. Yeah.
It will take. I was thinking that she's saying that 1 1 1 1 1, all the elements are same.
No, I was assuming while calculating it, I was assuming like 1, 2, 3, 4, and the next, the first row is 1, 2, 3, 4, and the next row is 2, 3, 4, 5, something like that.
Oh, okay, okay. Then also,
because it's increasing in the row wise and also it's increasing column wise. Okay, so I assumed something like this. When I applied that, this didn't work out. Then when I assume they are distinct, then this answer came. Hello, am I audible?
yes, 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 yes.
Yeah.
Audible.
I assume that
Yeah,
in
yeah.
each row.
Yes, yes. Got it, got it, got it. Same, same. It will take the same.
Yes, sir.
Hello, sir.
Yes.
Sir, can you explain the recurrence relation once? I'm not getting it.
Recurrence relation. Oh,
Yes.
okay. Okay. Oh, okay. So anyone knows? I have already taught some, not taught me some part of it. I have uh, given a brief about the recursion in the week 2 or something. I know. So anybody knows, right? Everyone knows, I think, but some of you are maybe not know that what is recursion and how it works. So can anybody make us understand what is recursion and how it works? Means call stack, recursion call stack also. So because you know that everything is calling itself, so it is recursion. Okay, so give me one example. Definitely you have tried by yourself and you you would have faced some difficulty, right, while solving some problem. So can you give us a problem? Because otherwise I can take an example of, you know, that some factorial or Fibonacci something. If you can give those examples, then it will be better for you also. Otherwise we can take any example like factorial something n into fact n minus 1. If first search using recursion. So Snehil, can you make us understand this, that DFS problem with only recursion part? I can give you, okay, I'm just writing factorial problem and we'll discuss another problem also. It is just basic, right? Yes. So who asked this question? Recursion.
Sir, I have asked.
So
Recurrence relation.
yes. So for n is equal to, so what did you understand about recursion? Anything or
The
basic?
function is the function that calls itself.
Okay. So you understand this, right? So
Yes, I know what is recursion.
so what is your problem? Means
I have
what do you want to ask?
I want to ask how to find a recurrence relation of a function, recursive function.
Oh, okay,
I don't know
okay.
how to.
Oh no, not okay, okay, not recursion, recursive relation.
Yes, I have recursive relation. I know
Oh,
what is recursion.
oh, okay, okay. Yeah. So recursive relation, okay. So I have already taught this how to calculate recursive relation. The same way we calculate time complexity, right? The same way we calculate the recursive relation also.
So can you show one example to calculate the
Yeah, I am
recurrence
thinking.
relation?
For this equation, okay, for this, okay, we'll do for this one. Okay, so we want to calculate the time complexity. Sorry, what I am saying, time complexity, the recursive relation.
Yes, sir.
Yeah. So want to calculate the recursive relation. So what it could be? The same way we want to calculate, suppose Tn. Tn we want to, this is the time complexity. So that is also the recursive relation, right? We are just writing something. Tn is equal to, so what could be? Suppose n is equal to 5. So what we are doing here?
It will run 5 times then.
Means that's what is the recursive relation. That means every time we are checking that n is equal to 0 or not. If not, then we can return 5 into n minus 1 means 5 into 4. So every time it is running, right? So every
Yes,
time,
yes.
so we can say that Tn is equal to n into Tn minus 1. We can say
Okay.
that Tn is equal to n into Tn. Yeah, this is the Tn minus 1, because for this one it will be Tn minus 1, and then it will go, and then it will be Tn minus 2, Tn minus 3, Tn minus, so it will go, if it will go to 0, then it will be 1. So recursive relation, what could be recursive relation? Recursive relation could be n into Tn minus 1, because by this way we can calculate the time complexity also. So this
Okay,
is
sir.
also recursive, means the way you calculate the time complexity. So how you calculate the time complexity? By the recursive relation also we can calculate time complexity, right? So the same way we can write here that recursive relation also, that n into something Tn minus 1. So this is also a recursive relation. So I don't know, means it will depend upon the question to question, so how to calculate the recursive relation.
So you can see that practice assignment 2, in the week 2 practice assignment, the first question there I'm getting it is like I'm showing one second. Let me see. Uh, assignment 1. Yes. Yes, there is 2t n minus 1. I'm getting this. It will be like this 2t n minus 1, but there is extra plus 1 added. I'm not getting it. Why there is
Week
plus
2
1?
PP1, right?
The practice assignment. No, not practice program. Practice assignment.
Oh,
Not
okay.
programming one.
Yes, yes.
The first question you can see.
Okay. So here I have taken this example earlier. So you know that Tn minus 1, Tn minus 2, Tn minus 1. Okay.
Yes, I'm getting this.
But
Yes, like 2t n
why
minus
I am adding 1?
1. Yes,
Because whenever you take some value n, so it will run first n time, right? First time it will run. Suppose if we are taking 5, something, so it is just running one time,
yes.
if n is equal to 0, then return 1. So it is running one time, right?
Yes, 5.
And
Then
then
it
it
will
is
go 4.
Tn minus 1 plus Tn minus 1. That's why it is 1.
Okay.
But in the while calculating the time complexity, definitely this will not affect much. But the exact recurrence relation when we write, then we can add plus 1. So that's why plus 1. You understood, right? Plus 1, why plus 1?
So
Because
for the factorial one, there will be 1 will be added or not in the factorial one?
yeah, it will be, yes.
Okay.
Because
And now I got it.
it was
Yes.
running, right? It was running, then it will come here.
Okay, I got it.
Because this Tn minus 1 we are calculating for this, right? Tn minus 1 something, if we are denoting whole time complexity Tn for whole this one, and it is running one time, so that's why plus 1. So here also it will be plus 1.
Oh, yes, I got it. Thank you, sir.
Sir,
Yes.
in the same problem, you go back to this practice assignment problem.
Okay.
The same problem. Yeah. Suppose I am just modifying a little bit. Fun n. After that, if I have one more line, count is equal to say count plus 1. Okay. Initially, I define the count is a global variable, and this on if I add that step into the program, then this Tn will be Tn is equal to 2 of 2t n minus 1 plus n plus 1, right? Hello.
Hello, yeah. So y plus n, I am saying y plus n. If you are
Because
adding plus n, it means that it is running n times. It should be run extra n times. Okay, then tell me why it is n.
why? Because why I am every time this function call, this count is equal to count plus 1 will be operated.
Okay, yes, yes.
That is why it is plus n, right?
No.
Has to be na. Otherwise this see
Okay, okay. So okay.
see, if n is equal to 0, return 1, this block will operate only one time in the whole life cycle.
No, actually nothing. That's why I didn't say that. That's why it is plus 1. What I am saying that Tn is time complexity. Tn is time complexity of the whole algorithm. Okay. So Tn is whole time complexity, and y plus 1, I was saying that if we have any number of n is equal to 5 or 4, so it will run at least one time extra. Okay, for this one, for Tn, if we want to calculate Tn, then it is checking that if n is equal to 0, no 0, then it will come to this one. So it is running extra one time. It is
Every
running
time.
Okay, Tn is equal to, Tn is a time complexity of this. Okay, then it is running one time, agree, one time plus.
Sir, one
and
time only return 1, this line will execute only one time. But if n is equal to 0, this particular line will check n times. It is not true. I agreed. If n is equal to 0, this condition will check in every function call.
You didn't understand. Tn is time complexity of this, and Tn minus 1, whenever this Tn minus 1, so it will included in the Tn minus 1. It will already included. If n is equal to 0, return 1. This statement is already included Tn minus 1. That is why plus 1, because in Tn we are including this. And if we will calculate Tn minus 1, then Tn minus 1 will include this. It will not extract, it will not add plus 1 for this Tn minus. We will not add something, that how to say, means it is just means it is accumulating this statement.
Excuse me for a minute. Hello.
Yeah.
Actually, the problem is write down this recursion, like what you wrote for factorial. Could you go to that?
Okay.
The problem is when n is equal to
so you
plus
are
1. This is what.
So your voice is breaking.
So when you write Tn is minus 1 plus 1, right?
Yes.
The problem recursion, you will it's appearing many.
So your voice is breaking, I think.
Uh,
Is it everyone, for everyone?
Yeah.
Can you hear me now?
No, in between breaking.
Can you hear me now?
Yes.
So recursion relation problem comes in. So if you complete this recursion relation, Tn is 1. No, it is not n minus 1 plus 1, right?
Yeah.
So there won't be in front.
Yes.
Yeah. So now go to the second stage. And
second stage, yes.
n factor in front of Tn minus 1. The equation which we have just written.
So I cannot listen you because your voice is breaking, right?
Am I audible now?
You are audible, but you are breaking.
Just a minute. Is it fine?
Yeah.
So when you this equation, Tn plus 1, right? There won't be.
So your voice is breaking. You can write in the chat box.
Okay, let me write down.
So what he is saying, you just this is the first unfolding you have done. Now you unfold again. Go for the n-2 term and write it here. That is what he is saying.
So I have written down in the.
I'm thinking. Yeah, I'm seeing it. I'm seeing it. Do not write. Okay.
Yes, when you are open everything, that will comes as a n, and that's what I am saying.
Yes, you are right. But do not write in chat. Okay, speak, everyone.
Okay. Sorry. So
No.
it is. So if you unfold it.
No. I'm not saying you. Your voice is breaking.
Okay.
So Naveen Gaur is you, right?
Yeah.
Yeah. You please write in chat box.
Okay. I think now I'm audible. Probably there was some. So now when you
No, your voice is breaking.
Okay,
You please write.
okay.
Yeah, I got your point. Yes, I got your point, because the same thing, only these things is doing, means it is just contributing. So for n time, it is, we calculate that for n time we are just +1 +1 +1.
Yes,
so
sir.
it will be n.
Exactly.
Exactly.
That is what is order n.
Correct. So whatever line, if I write some more line between the function and if statement, and that do not have anything,
No,
nothing.
then it will be n, means then it will be +1.
No, sir. What I am saying, sir,
Mhm.
sir, if I write any line in between this function and if statement,
Okay,
and
okay.
that those particular line if do not have any relation with the order input order, then we can collapse all those things in the one block, and every time we will calculate that 1 + 1 + 1. That's what I am saying, sir.
So you were saying that +n+1, right?
No, that +1 will ultimately get executed, because that return 1 will finally get executed.
No, means you are saying that if it is executed, then it will be +1. You are saying this one, right?
No, I am saying ki every time when you are calling this function, it will have a tn-1 +1. This +1, because of if n is equal to 0, this
Yes.
particular line get executed.
Yes.
It's
So
keep on building up to n step. Still it get, that's what I am saying.
If you if you include some steps, suppose if you are including some step here, count something, so again it will be +1. Okay.
Yes, that is get collapsed into the one block, because it is
That's
not
what it will
nothing
not
doing
be,
with the n.
because earlier you were saying +n+1, so it will be calculated +1. The same thing will be calculated +1, because every time we are running +1 time, it means we are running plus, each time we are running, so whatever the line will be, so it will be counted as a 1.
Yeah.
Okay, so we have discussed it, so time is already
What will be the answer?
9. Answer is, you know that my answer is 2tn-1 plus 1, and 2, because of this 2 it will be 2 to the power n. So shall we stop?
Sir, in the means exam, sir, this shall we need? Oh, we need not to write anything, right? This all are objective. Okay.
Yes. You don't need to write. Whatever the exam query will be, you can discuss tomorrow, because tomorrow session will be on quiz. Today's was on week 5, but we haven't discussed on week 5. So I don't know week 5 session will be there or not. I don't know about that.
Sir, is there any session in Friday?
No, only
Is that-
Thursday. This week we have only 2 sessions because of the quiz. If we have a Friday, then how do you at least all of you will have some time to prepare for quiz. That's why we remove one session.
So deadline of week 5 and 6 are same.
Yeah, but it will be extended. It will be extended.
Okay.
But you can
No,
confirm.
it is showing only 6 Feb.
But definitely it 6 Feb. So exam is 30. So then you will have a time to
We
complete.
will have
It is already,
1
I
week
think,
for both
extended.
weeks. I mean, for week 5 and 6, we have 1 week only.
Okay, okay. So actually
I
tomorrow
don't think
session,
that they will extend the deadline.
tomorrow session is our like they those instructor will take, I think Atul will take. So he is the leader of the PDSA, something like. So whatever the operational query or 5 6 or something limitation, you can ask him. He will uh, he will give you a right reply on that. Means he knows actually. So he is leading, that's why.
Okay, sir. Thank you.
So shall we close?
Yeah. Thank you. Good night, sir.
Thanks. Good night everyone. You can leave now. Everyone can leave now. Thanks everyone. Good night.